Okay, this Hangout's on air.
Hey everybody, we got this board game. It's us. We're doing this live Hangout on air. This is the show and tell that we do every single Wednesday at 7:30 p.m. It's me, Lady Ada. I'm here at the Adafruit factory. We've got these awesome puppets over there. Check them out. They're so cool, and some awesome demos and like a little planter. And we're gonna have some fun time. We're gonna have you, the viewer, show off your project. So tell us what you're working on. We're going to be here till 7:50, 7:55. Please be quick because it always takes a little longer than we think, and we have to get ready for the next show. So we're going to start off with Phil B. from Adafruit West.
Hi.
What's going on?
Hi. Fun stuff. I just wrapped up a project here. Hope you can see this. It's so darn tiny. This is, for the next like 10 minutes maybe, is the world's smallest playable functional MAME cabinet. There's a Raspberry Pi Zero on the back and a little tiny OLED screen out of the shop. And I wrote some software that works kind of like FBCP and actually puts the MAME video onto the little OLED. And it's actually playable. It has sound and a little joystick. And to be honest, it's cute. It's neat to look at. I did write a guide about it, and I want to temper people's expectations. You know, Noe and Pedro have set the bar really high with like, you know, the Pi Girl projects and stuff. This isn't going to be something like that. This is just you know, this is stuff I've worked on. And I hope maybe someone learns something from it or makes one even smaller would be cool.
And that's 96 by 64 pixels.
Yeah, it's barely playable. You know, I think I'm only playing it through muscle memory. You know, from when I played these as a kid. It's
okay.
Barely legible, but cute. It's cute. It's fun, and I hope people like that.
Okay. Awesome.
Excellent, right? It's so cute, and I like that.
I just want to eat it.
I like her. Like, I'm not going to beat Noah and Pedro, so I'm just going to go tinier. No, I just like that was the strategy.
I love that it actually plays MAME. Like, you could actually like, and you can rotate it and play Nintendo games.
Yeah.
It's a terrible idea, but you could do it.
Yeah. So you can probably. I can't see what I'm doing, so I'm going to get at here, but hopefully.
Go down. Go down.
Yeah. Yeah, I like the top lights up too. Good.
Yeah, the little marquee light was the finishing touch.
Okay. All right. Sweet.
All right.
Nice
Thank
work,
you so much,
Philby. So cute.
We'll be showing some videos on Ask an Engineer about it tonight too.
Oh, cool.
All right. Noah and Pedro, who are now building a 50-story version. No.
We have to go bigger. We have to make it like a full-size one.
Yeah.
Yeah. So also wrapped up a project. This is Circuit Playground Yo-Yo. It's got some 3D printed parts and some CNC milled parts, but it can all be 3D printed or otherwise made out of clay or something. I don't know. Yeah, this is tomorrow's project, so there'll be a video and a guide along with it, and just planning a lot of Halloween stuff. Mm-hmm. Yeah, that's about it. All right, cool.
Okay.
Check out tomorrow. We have some other goodies.
Yeah, we have your time-lapse video and then also the yo-yo video.
Awesome.
We'll be playing that tonight. Okay.
Thanks, guys.
All right.
Next up, Scott, part of the Adafruit family now.
Hi.
Yeah, it's super exciting. I'm part of Adafruit.
Yeah.
Cool.
We give people little cards, and if you come on show and tell enough times, you just end up working with us.
Yeah. It was pretty simple.
Yeah.
It was pretty simple.
You trade in 25 of those
Yeah.
a job or like a really cool spider ring, you know, like a little plastic ring.
Yeah.
Yeah, I was tempted by the spider ring.
50,000 and you can get the boombox.
Yeah.
Yeah.
All right,
it's like Discovery Zone. Anyway, so the work I'm doing for you guys is stuff I'm really excited about. I'm doing MicroPython. MicroPython, as those of you who have seen Tony's videos, is a re-implementation of Python for microcontrollers. And I've been working on getting it working on the feathers. So what I've got here is I've got the feather BLE and then the just the like regular colored LED thing on top. And I just got I2C working. So if in the background I have a Chromebook here, which is cool. So I'm using like a terminal from Chromebook to talk to the feather. And I already typed in the code. So if I just get it going, now you can see that like all the lines are animating. So I've got I2C and MicroPython working, and we should be able to build a bunch of drivers that take advantage of that.
And this is really neat because, you know, one of the things is like your Chromebook doesn't need a compiler because you can't install compilers on Chromebooks, so you can't use the Arduino IDE. So this is a really good alternative to doing it. And so like what kind of stuff do you think you'll be able to do with MicroPython? Like can you do sensors, analog reading, PWM, like?
Oh yeah, so the PWMs and the digital I/O is all, the basics are done. I did that earlier, like a couple weeks ago, but it's, I think I showed it on the show and tell where like the LED was going on and off. So those basics are there too. Where I'm going with this is like the I2C, SPI, like the stuff that you need for the fancier sensors. And then we'll have Python libraries on top of that that make it really, really easy to use, similar to the existing Arduino libraries. And then I'm also working with the MicroPython people to make it uniform. If you've read Tony's guides, he's like, but if you have this board, do that, or that board, do this. So we're working on getting those consistent as well.
Cool. All right. Very exciting.
Okay. Brad.
Thank you for the update, Scott.
All
Okay,
right.
that's Adafruit, folks. So let's.
Well, we'll just keep going. Richard, how's it going? Welcome back.
Hey guys, so I got a couple of really quick projects to show off here. So this is something I've been kind of working on for a while. This is a particle photon and an NFC reader. And what we're wanting to do for this is that, so we have a lot of machines here that we want to be able to track access to. And some of the machines we charge like per minute for people who are certified. So we're going to start giving them all these little NFC cards. And when these will be attached to each of our machines with a relay, and when you put the card in a slot for any machine, it will enable it so that then they can actually use that machine, and then when they pull it, it actually makes you keep your card in there. So you only have one card, you can only use one machine at a time, and then when you pull your card out, it turns off the machine. I wanted to hook it up to the Photon because I want to actually track in our database on our website what the usage is for that, so we can do for billing and maintenance and a lot of things. And then also, this is something that I really want to share with a lot of makerspaces, because in a lot of cases, this is the kind of thing that can make it much easier to get insurance for something like a wood shop, because this actually controls access, and that's what the insurance companies really want. So a kind of fun, quick thing that we did for Maker Faire is we get a lot of questions, especially when it gets to the electronic stuff. So I made up these boards that actually have a lot of examples of microcontrollers. Of course, we have the Arduino Uno and a bunch of the Adafruit boards, and even some of the these little guys, the DigiSpark things, which I supported. Actually, I found out about these right when you guys were coming out with the Trinket too. So I had have a couple of those. And then we have our Internet of Things board, which, of course, has the Edison, or the Galileo and the Edison, and pretty much, other than the particle photon, pretty much all your guys' boards on there, too. And unfortunately, when it comes to microcomputers, the only thing I have is an original Raspberry Pi. So we figured a BeagleBone Black is a little bit too expensive to kind of just put on a board for display. But these are all Velcroed too, so we can pull them off when we're not showing.
I love it. I love that it's like a cheese plate. It's like a sampler. You know, you get, you know, you can see them right there. It can really help identify. Okay, how big are they in comparison? What things do they have on there? That's cool.
Yeah, we get people who come into the space all the time, and we start just talking about Arduino because it's here, and forget sometimes that people have never even heard of these and don't know what we're talking about when it comes to microcontrollers. So it's really good to kind of show them where they started and like what you can get now, like how small they are.
Yeah, there's a menagerie of them, and then some of them evolve, and then some of them are on Galapagos Islands, and they have like duckbill and stuff. Like it's kind of neat. Like there's all sorts of ones.
Menagerie.
Someday we'll have as great a library as you guys have for the Arduino Museum.
Yeah, I still have. I showed this one off last week. This is the rare red one.
Ooh.
Yeah.
This is when Arduino made a small number.
This is back when it was on Brilliant.
Yeah, and then this is the first Arduino. You're sitting right here. Okay. All right. Well, thank you so much.
Yeah, they didn't have the Arduino domain name yet. It's cool.
All right. Next up, Aiden. How's it going?
Hey, Aiden.
Hi. Before we get to my project, I want to talk about what Richard was saying, because I'm actually doing something quite similar for the engineering/maker department at my school. So we have tools like bandsaws, drill presses. However, it's hard to keep track of if a student has actually been taught how to use a certain tool. So we're giving little RFID cards, and we have a very similar system that I'm working on, where if a kid has learned how to use a certain tool, we can update their card so they can put it up to the little 3D printed box with a feather and a RFID reader that's connected to the tool, and it allows them to turn it on and use it. Whereas if they didn't learn how to use it and didn't have their card updated, they wouldn't be able to. So something quite similar that I found very cool. Anyways,
Cool.
what I have today is not quite soft robotics, but definitely related to 3D printing and compliance and compliant materials. So this is a 3D printed NinjaFlex bouncy ball that I made a while back. And it doesn't work super great. I just had a normal standard grid infill on the inside. And because of that, it bounces really irregularly in both where it bounces and the height by which it bounces. So I was trying to think of what would be a cool way, and an interesting way, and a novel way to get better and more consistent bounces with 3D printed balls. So Angus from Maker's Muse, a popular 3D printing channel, showed how to make this interesting three-dimensional infill, which is basically a lattice pattern. And he was thinking of using it with SLS printers to save on materials cost. But I saw that it could be very valuable for reducing materials while maintaining or even changing compliance and elasticity in soft structures. And so this was kind of a first prototype. It was a bit too hard and dense. And then this one is the second one, which I just finished the other day. I'm printing a third prototype right now. However, this bounces really well. I can even show you.
Wow, that is really good.
It bounces up, whereas this one...
That's terrible.
No, bad.
Do not tease super bouncy printed super ball.
That's nice. That's really cool that it's using that 3D mesh lets you have more flexible stuff. I mean, that's really great for soft robotics. If you're going to have three-dimensional shapes and you want them to be consistent.
Yeah, because I've always thought about having to if I'm making a soft robot out of silicone, having to use different silicones of different hardnesses and softnesses for different parts if I wanted to have varying stiffness. However, I've realized that if I can create a simple geometric structure that's easily repeatable, I can replicate that varying of durometer.
Yeah. What's the technical term for the bounciness of something? I hope it's bounciness, but
I'm not really sure. It's kind of a combination of durometer, compression, and elasticity.
all right. I have a feeling that there's an opportunity to name bounciness. So
You can name it after yourself.
yeah. All right.
Adenacity.
Yeah. All right. Well, email support at adafruit.com and you have a sticker for the side of that ball. All right.
And it fit, I think.
It would. It might affect the bounciness, which
It's going to be a different word soon.
yeah.
Yeah. Okay. All right. We're going to go to Lon and then Roberto.
Hey, gang.
Hey.
So back to our space gun project from a squirt gun. The update, I just stopped streaming like a minute ago, so I have to configure things.
I know exactly how you feel.
No, you know how it's like.
I know exactly what that's like.
You have no idea. Yep. So the big change is we cut it up and started getting... oh, my screen is blinking at me weirdly. Oh, Hangouts. Well, hopefully you're seeing it.
I see it.
So the big change was I did some experiments with the speakers. So we're using your 40 millimeter plastic frame speakers. And I won't take it apart right now, but basically there's a PET plastic tube in here that contains a sandwich that has the speakers. They're about 30 millimeters apart. They're firing in phase, mono, in the airtight tube. Theoretically, that can give you up to like a 6 dB gain. I'm seeing about a 2.5 right now, so that's awesome. And then there's a little styrene spacer, and then the NeoPixel rings on top of that. And I just realized after stringing all the wires, so fun things, fun stories along the way. So yeah, mounting the speakers like that drastically changes the sound quality. So if I can get.
Wow, that's loud.
It's loud, and there's some bass in there. It works out super well. I'm super enthused about that. Mounting the alphanumeric display, the board. Once I made this into a tube and changed that part of the design, then the backpack didn't fit in this slot anymore. So I had to separate the display from the backpack. So desoldering those 18 wires and then resoldering 18 wires on both ends was lots of fun. And then the fun story was when I started working with the accelerometer, and I didn't have time a couple weeks ago to talk about this, is at first I used those ones with the analog outputs, and that was kind of a problem. And it turned out that one of the problems I was having wasn't the accelerometer, it was the speakers. Because the speakers, firing back and forth, are imparting a vector movement this way, an acceleration that was showing up on the accelerometer.
Yeah.
So I had to account for that. So that was kind of a fun thing to debug.
Ooh.
And then the new mode, I just realized it's going to be harder to demo nowadays, now that there's things wired inside the gun.
Okay.
But the new mode is the soundboard mode. So the idea is you can aim the gun in different directions and get different sounds. So this is for a specific conference, but if you aim it up, it plays a different sound.
Oh, that's cool. You don't have to switch it.
So I've defined 6 different positions of the gun, and then 2 levels of pressure for the trigger, and so you can play 12 different sounds by aiming the gun and pulling the trigger.
Okay.
So that's where we're at. And
this is like it has its own operating system.
Yeah, Lon, I had one quick question. How did you get rid of the vibration of the speaker with the accelerometer, like you were saying you were debugging? What was the solution?
So the solution was Lady Ada put that audio sensing pin in there, and so basically I don't monitor. Well, in most of the modes, I don't read the accelerometer while the audio is playing.
Ah.
Because you can ask it like,
Yeah.
is it playing? There's a little pin that goes high.
Yeah, that's cool.
Yep. So I check that pin, and if it's going back, I just return the last value.
Very clever.
Okay.
All right on. Okay, we're going to go to Roberto, and then we'll wrap up with another Phil. We have excellent full market share tonight. Okay, Roberto.
Hi, guys. Can y'all hear me all right?
Hey, Roberto. Yep.
Okay, cool. I just have 2 quick things. So the continuation from last time I was here is that I ended up using the LED knuckles enclosure for the feather.
Mm-hmm.
And I wanted to show how I've gotten into more OpenSCAD and have, this is the model from Adafruit on the right, and then this is the one I'm working to hole out and scale down so that it fits just right for the alpha quad. So I've been working on that and haven't printed anything yet for it, but once I have something, I'll come back and show it. The other thing was for the yo-yo, it's been really fun to work with it, and I'm trying to get back to. Y'all see me? Y'all see me, right?
Yeah.
Okay, cool. So my addition to the circuit playground was to add Mike Parea's kaleidoscope code that gives the X angle, and so that's what's running on this. So you'll see pretty much the same thing he did, but once I had the angle, I ran it through the map function, and so it'll play tones.
Oh,
y'all can hear that, but one of the cool thing is like
a neat idea.
It really reminds me of.
Oh yeah.
Huh.
Yeah, it's like it's just using the tone library and mapping it from whatever the 0 to.
It's like a little robot.
0 to 360 angle is, and then it maps it to the corresponding tone value. But what was for me was cool was that for a long time I've been wanting to work on Mortimer Ichabod marker, which is the musical pin from picture pages back in the day.
That's right.
And so this is really what made me happy, was like, just have something like that that's spitting out tones And I showed it to my son, and he was like, "Wow, how'd you do that?" And I was like, "All right, kids."
Now
like
that's
it.
cool.
Yeah. So thanks for having me again.
All right, sweet.
You know, a million years ago at Make, I was telling people about picture pages, and the staff that I was talking to was young, and no one knew what picture pages were. So.
Yeah.
Excellent. Finally.
Yeah,
it wasn't a weird dream. There was a talking marker thing. Okay.
Yeah, I meant to screen share where the source code is at, but maybe I'll just send an email and let y'all know.
Block it up.
All right.
Okay, Phil, you have 2 minutes, 3 minutes to. We gotta go.
Okay.
Hey.
Really quick. I'm working on a mini rover.
Oh, cute.
And it has an HCSR04 ultrasonic sensor on the front of it. And this is going to use Python to do the room mapping with R. So basically what it does is it records the, as it runs around the room using a random walk, it will record its location based on wheel turns, and then the range to objects using the ultrasonic sensor. And it records this, several thousand times. And then I pipe those data into R and use a kernel density estimate algorithm to create a contour map of the room.
Cool.
In the sound map. And I want to say the LBO pin on the PowerBoost 1000C is awesome for a Raspberry Pi powered robot because you can actually shut the machine down cleanly when you run out of power.
Yay.
So that's what I'm working on right now.
Okay,
yeah,
cool.
I saw I think you did a Periscope where you put a video up on Twitter. I saw some of it. It was somewhere. You put it somewhere.
Yes. Yeah, I put a YouTube video up on.
Right. It's cool that there's more than one video place. I'm like, which one was it? Which was the little picture icon? So I think you linked to it on Twitter, and it had the thumbnail of the YouTube video.
Yeah.
That's it. All right, we'll keep it up. And
Okay.
of course, to get a sticker, email support@adafruit.com, and we'll send you out one in the chat that we're at. I have my 2008 post on Make about the picture pages thing. When Gerardio came out, we talked about it, and we said, hey, it's kind of like picture pages. Anyways.
Picture pages. Okay.
Yeah, Make is like my backup brain because we had
I know.
I would post like 50 things a day. Anyways.
Okay.
All right. Well, this is a great show and tell.
Sweet.
Thanks
We
for
ended on time too.
playing along, everyone. This worked out really well. And for the folks watching, the way Hangouts work now, it did work out good. There is also a YouTube style or a YouTube chat that's going along with this instead of it being how it was before. So you can do live. There's the
It's
chat
now
room.
live. Yeah.
So that's kind of neat too. So for all of you folks in the chat room watching, you too can be on the show and tell.
Is that the same as this chat?
No. This is
There's
just
two chats.
This is our chat.
Oh my god.
And then this is the YouTube chat over here.
All right. I mean, that's fine. I guess it makes sense.
Yeah, this is our secret chat.
Secret chat. Okay.
Okay. All right.
Good for secrets. All right. Thanks, everybody.
Scott. Thank you,
Scott,
Roberta.
Roberta,
Thank you,
Richard,
Thank
Phil.
you, Phil.
Another Phil.
Thank you, Phil. Thank
No,
you,
Pedro.
Thank you, Lon.
Lon.
Thank you,
Bouncy
Ian.
balls.
Yeah. We'll see everybody here next week, 7:30 p.m. Eastern time.
Yay, it worked out.
Yeah, of course.
People were all like, how's it going to work
It
out?
was
How's it
going to be okay.
It's
It's all going to be
going to be
okay.
okay.
It's all going to be okay. All
Worked
right.
it out.
Bye, everyone.